This is the skills practice for 6.6. It's on the Pythagorean theorem. We're going to find the missing measure in each right triangle, round to the nearest tenth if necessary. Now, we've been rounding to the nearest hundredth all year, so that's 2 decimal places. So remember, to use the Pythagorean theorem, you need to have a right triangle, and all of these are right triangles, so that's fine. You need to know 2 of the sides. You can always find the third side. This first one is a special one, 3, 4, and something else. If you remember your shortcuts, there's a triple, 3, 4, and 5. So you don't have to do any work. You know that hypotenuse is 5 because the legs were 3 and 4. Number 2, again, it's a right triangle. You have both of the legs. You need the hypotenuse. Well, 10 and 25 don't appear to be a triple from my list. So what I'm going to do is, remember, when I have both legs, I'm going to add. So if I want my hypotenuse, here's what I'm going to type into my calculator. 25 squared plus 10 squared, and I'm going to take the square root of all of that. And it's probably going to give me a decimal. So I'm going to type this in now. So if you're using this calculator, notice, remember, this is where the square root is. It's the x squared button. It's the second function. So we're going to hit second, x squared, then we're going to type in 25 squared plus 10 squared. Hopefully we do it correctly. And it'll give me this answer, which is bigger than 25, which makes sense. This is our hypotenuse. 26.93 is what I'm going to call it, because 92 is going to round up to 93 because of the 5 after the 92. 26.93. We added there because we had both legs. In this problem, you have a right triangle, but you want to find one of the legs. So you have this hypotenuse and this leg. So this is where you subtract. So you want to find a leg. We're going to do 33 squared minus 20 squared, and we're going to take the square root of all of that. And again, it's probably going to give you a decimal. 33 squared minus 20 squared. 26 point, I'm going to call it 25 because the third digit is 5 or bigger. 26.25. This answer makes sense to me because it's less than the value of my hypotenuse. I'm going to skip down to number 7, and I picked this one on purpose. You have 2 sides of a right triangle. One is 3, one is 5. Don't make the mistake in thinking that you can use this triple, because look at the legs. The legs are 3 and 5. Here the legs need to be 3 and 4. So it would be a mistake to think that this hypotenuse is 4. This is one of those ones where you need to add because you have both legs. We'll do 5 squared plus 3 squared and take the square root of that. So we get 5.83. The next section down, 10 through 17, is the same exact thing, except they don't give you a picture. So they're telling you these are right triangles. Find the missing measure. If C is the measure of the hypotenuse, so C is your hypotenuse, obviously, A and B are your legs. Round to the nearest tenth, we're going to do hundredth if necessary. So here's number 10. You have A and B. Those are your legs. So here's what you're writing down. 15 squared plus 10 squared equals your answer. And it better be something bigger than 15. $18.03. That makes sense because it's bigger than 15. Let's look at number 11. We have a hypotenuse of 10. We have a leg of 6. What's the other leg? Well, I know my triples. There's no 6, 8, 10 on here, but there is a 3, 4, 5. If you multiply 3, 4, 5 by 2, you get 6, 8, 10. So I know that the other leg is 8. 6 squared plus 8 squared equals 10 squared. Now, if you didn't know that, then you would just subtract. You would do square root of 10 squared minus 6 squared, and it'll give you 8. But that's a quicker way to do it using the triples. Number 16. We have a leg that's 7. We have a hypotenuse that's 15. Again, I picked this one on purpose. Well, it kind of looks like it might be a triple. You got a 15 here and a 7 there. We're going to type in square root of 15 squared minus 7 squared. And that gives you 13.27. We're subtracting because we had the hypotenuse.